All right, so we've got a little more complicated rational function here. Thankfully, it's already been factored for us, at least in the denominator. We will note that the numerator is not factorable, right? X squared plus 4 is going to have complex roots, so we're just going to say, hey, it's not factorable. Maybe, there we go. And so we're going to say, okay, great, what's our domain? Well, we've got to throw out 3 values, one for each factor in the denominator, right? So we've got to throw out x equals 0. That's the easy one to miss. We've got to throw out x equals -5, and we've got to throw out x equals 2. Because any one of those is going to cause us to have a divide by 0 error, right? So we'll go ahead, we'll kind of, I didn't put graph paper on here, so we will sketch out some stuff, right? 1, 2, 3, and of course we have a vertical asymptote at 2. We have one at 0, and then -1, 2, 3, 4, 5, 6, 1 at -5. All right, and 2. Okay, so what are our vertical asymptotes? Of course, we know this already because there are no common factors in the top and bottom, so there are no holes. So our vertical asymptotes, x equals 0, x equals -5, and x equals 2. And then we can say, well, is there a y-intercept? There's no y-intercept, right? Are there any x-intercepts? No, because we have x squared plus 4 equals 0. That's going to be complex. So no. Is there a y-intercept? No, because it's not in the domain. So this one, you kind of just have to plug in a few numbers and see what you get. We could plug in x equals 1. And we could say, okay, what are we going to get there? We're going to get 1 squared plus 4, that's 5. 1 times 6 times -1. So it's going to be -5, 6. So we're somewhere down here, and that tells us right away that our graph has to be doing this because we can't cross the x-axis and we can't cross the asymptotes, right? We could try x equals -1, and that's going to give us 5 over, let's see, -1 times 4 times -3, so that's going to be positive, right? Positive 12. So at -1, we know we're like here, let's say. And so again, we know our has to be doing something roughly like that because we can't cross the x-axis or the vertical asymptotes. And then we can do the same thing with, say, 3. So we're going to get, what's 9 plus 4 is 13. And 3 times 8 times 1, 24. And so that's positive. That's all I really care about because that tells me, hey, it's going to be doing something like this. And then we can say, well, let's pick like -6. We've got 36, 40 over -6 times -1 times -8. So that's going to be negative. That's going to be, what is that? 6 times 8. I don't really care. It's a negative number. That's all we really matter about, right? So we're going to say, oh, and it goes like that. And again, we know we can't cross the x-axis or the vertical asymptotes because there's no x-intercepts and you can't cross vertical asymptotes. So what is happening to this graph as x gets really, really large? Well, the denominator is like x cubed and then some lower terms. The numerator is x squared, so the denominator is going to get bigger faster than the numerator, and it's going to go to 0. And we see that in the graph. So as x goes to infinity, we see f of x going to 0. And let's take a quick look at that in GeoGebra. So we've got f of x, or y, equals x squared plus 2 over x times x plus 5 times x minus 2. And I make sure I put the times in there because sometimes it thinks it's function notation. And you can see that this pretty well agrees with what we had. And as we zoom way, way, way out, you can see it getting really, really, really close to 0 for the y value. All right. So we see our x-intercepts or vertical asymptotes. There we go. That's what I'm looking for. X equals -5, x equals 0, and x equals, what was it, 2. All right, there's all of our stuff. So there we go. That's going to bring us into, however, we see that graph going off to 0 as we get really, really large. This is bringing us into horizontal asymptotes.